and we're going to solder our nightlight is what we're going to do. But just so you know, I made a modification. I didn't like the way the nightlight was working. Here's the nightlight, and zoom in a little more. Blurry, focus. Okay. So bring the helping hands back. So here's our nightlight, and what I did was, it was still too bright and the nightlight was coming on. You notice I changed out the LED. Put a big fatty in there. What I did was, this LDR, a phototransistor, any of these actually, I went through all of them again. And what happened was it was barely getting the dark and the light was coming on. So what I did was I put another resistor in parallel with it. Actually, I believe it was a 43K resistor in parallel. Or maybe, no, I'm sorry, a 22K resistor in parallel. So it would have to get a lot darker before it would come on. As a matter of fact, so dark that I can't reproduce it here. I would have to go into the dark part of the room and then it would come on. So I'm glad for the tutorial we did what we did. But for actually getting this circuit to work, I added another component. And let me show you on the schematic where that component was added. And you see this 22K resistor here. We have the LDR, the light dependent resistor here. We have the trim pot, but we're actually using a 22K resistor. So I actually upped this one to 22K ohms resistor, as you see here. Right off of this same line here, I put another 22K resistor to ground. I just wanted it to be a lot darker when this light came on. It's a night light. It's not a evening light. Especially if you hook it up with a battery. But I'm going to show you how you hook it up to actually power too. We've actually got something that we can use to hook it up to power. And I'm just going to show you this device. We're going to solder it to build to the battery. So I just wanted you guys to see that. You guys are going to be sick of the nightlight by the time I'm done. We have this soldering tutorial with the nightlight. And then we're going to build the nightlight using a microcontroller. And we only need one resistor, one LDR, and the microcontroller, and then that's how we would build the nightlight with the microcontroller. And I'll show you all the programming, and we'll go into details, and we'll build that. And then we'll be done with the nightlight. We'll move on to binary, hexadecimal, all kinds of fun stuff. So, anyways, I just wanted to show you that. Hopefully that comes out okay in the video. So we have 1, 2, 3, 4 components hooked up to the same rail. So when we start to solder, we got to make sure we have at least 4 components onto the same rail. Okay, so let me put this aside. I'm going to use it as reference still, because I'm going to build the circuit on the proto board. But first we'll get into proto boards. And I showed you in the last video, or the video before that, these are proto boards. And you see they look pretty much almost like the breadboards. As a matter of fact, I'll open this one up, and let me just show you that, in case you want to go search for these guys on your own. I'm going to search for these guys online, because these proto boards are great. And hopefully I can provide a link down below. And so there it is, and you mount the parts on this side, and then you solder them on this side. Since this is going to be our only soldering tutorial for now, I wanted to mention a few things. When we start to prototype the integrated circuits, some of them are sensitive to heat. I can zoom in a little bit more now. Now these aren't, what you see in here is not an IC, but this is a holder for an IC, for an integrated circuit. And what happens is those ones that are sensitive to heat that we really can't solder directly, what we do is we solder one of these into our proto board. And let me bring up the board here. So basically what we do is we take this component, and it fit nicely right in there. And then we solder it on this side, these pins here, And then we could take the integrated circuit and just pop it right in there. We can pop it right in there. So we don't have to worry about destroying this. Now, some of the integrated circuits, you got to read the data sheets, because some of the integrated circuits are not heat sensitive or not as heat sensitive as some other ones. And some of them are. And if you want to be cautious, these are cheap enough. I'll put a link below for these guys as well. But they come in all sizes. This one I bought for a bunch of 555 timer chips. We'll be getting into those as well, you know, for flashing LEDs and doing all kinds of other things too, for timing of our circuits. So, like I said, they fit very easily into these proto boards. Just solder them on there, and then you just put your chip right in. The other thing I wanted to mention that I didn't mention in the video before, which is why I'm redoing the soldering video. When we do our nightlight, circuit, and we have this 9-volt battery, this is going to come on at night. And what's going to happen when the battery is going to burn out overnight? You're going to have to put on a new battery every night, which is kind of crazy for a nightlight. So if you actually want to use this as your first circuit, I recommend, and I will find these and I will put them online as well. Take one of these and you solder it to your board. You'll figure out your positive and negative. It's not that difficult. You just do contivity. Generally the inside is positive and the outside is negative. And you use your multimeter, which we have gone through, so you should know. Just touch the outside and touch which lead to see is positive and which lead to see is negative. I could tell you, but then it wouldn't be as fun for you guys to figure it out on your own. So I'm going to leave that for you guys. So, you know, if we built it into a case, we would take this screw off, we'd drill a hole in our case, we'd put this through there, and then this would hold it onto the case. We'd take some solid core instead of stranded wire, some solid core wire into here, and then solder it into our board, and then we'd take a 9-volt power supply, we'd plug it in, and there's our nightlight. We can keep it in all the time. I got more of these at work. Actually, I have better ones at work. I'm at home right now. So anyways, I just wanted to show you that. Another thing I wanted to show you guys, which I haven't showed you yet. I mean, I really haven't needed. And I don't use them much. In the winter, it's a good idea to use them. This is an anti-static wrist strap. And we put this into a ground, or we plug this in and there'll be an alligator clip. And as you can see, what you do is you put this on your wrist. Now, I'm a network engineer by trade, so when I'm dealing with network equipment and I'm putting in daughter boards or something, I will actually wear one of these, because I'm not going to blow a $10,000 board on some static electricity. I don't mind blowing a 13 cents PNP or NPN. But, so this is an anti-static wrist strap. You might want to think about getting one. Missing the other portion of it. This actually clips in, and then there's an alligator clip, and you can clip it to a grounding source. A screw on an outlet or something like that would work just fine. Okay. Let's get to it. So here's our board, and I'm just going to take the components directly from this. I'm going to take out our 9-volt battery here, declip it in case these leads touch. You could heat up this battery and cause a fire. So basically, here's our circuit, and I added one component, of course, and we want to solder it. So I have a piece here that I desoldered, and it would work perfectly fine. There's a hole in there. I don't know if you could see it. Probably. This is a pretty good camera. So this would work, but I'm going to break open another one and cut it just so you can see. Now this, believe it or not, this is enough connections for our nightlight. We don't need this big proto board, or even, let me open up this one. Now when I break this, see, these actually break in half, sorry. I don't know if you saw that or not. But, so now I don't even need this, but they don't break in half again. So this is actually a risky venture, what I'm about to do. because sometimes they don't split up the middle. Sometimes they'll deviate a little bit and they'll crack over here, and but I'm going to do it anyways. Just live demonstration, which I will include regardless of the outcome. So here we go in the middle, and usually they snap. There we go. See, now that one failed. Of course it failed because we're showing live. Now I could still use this for something. This is the side that we're going to use for our circuit, and I'll just clean this up a little bit. So as you can see, sometimes that can happen, and very rarely does it actually happen to me. It usually splits right up the middle for me. I usually get very lucky and it splits up the middle, but it didn't that time. And so what it did is it took out a whole bunch of the holes here. And I'll use that another time. But like for instance this one split right up the side here. You see it curved a little bit, but you know, both sides of this one turned out fine. And maybe we'll actually use, no, we'll use the one we just cut out. So that's our proto board. So let's get this stuff out of here. And we're actually going to desolder a component too. We'll intentionally make a mistake. I don't have any solder wick with me, but I do have everything else I need for this. And going over these components, I have pliers, wire cutters to cut off the ends. I have tip tinner, which is basically a combination of solder and flux. Flux helps the solder adhere to components. So one of the first things you do is tin your tip. I usually tin my tip at the beginning and at the end. So here we go. I'm tinning my tip, and hopefully you could see a difference in the tip itself. You should see a very silver end on the tip. And of course here is here's my solder cleaner. Clean the solder off the tip. This is great. It's much better than those wet sponges that come with anything. I've already told you guys about that. So I've tinned the tip. I'm putting this aside. This is my lead-free solder, and I believe it has a rosin core too, which means it already has this flux in it, so it already adheres pretty good to the components. Now it's more difficult to use lead-free solder, and in work I actually have a fan. In the robotics lab I have a fan that pulls the bad fumes away from me. I don't have one here now. It was just what I did was I took some filter from you could buy at Home Depot from an air conditioner filter, and used a 12-volt fan, and I hooked it up to 9 volts so it was a little slower. And it just sucks the fumes away. This is still not the greatest stuff in the world for you to breathe in, but it's better than the lead solder. So this is, I've seen it called non-lead and lead-free solder. That's what we're going to be using. And as I mentioned earlier, it's better to, if you start off with lead solder, and then try to switch to this, it's going to be a nightmare for you, because this is a lot more difficult to deal with. If you start with this and you learn how to use it, there's no need to go to lead solder. Now an old man like me probably doesn't make much difference of how much lead I breathe in, but I'm assuming you guys have a few years on me. Actually, I just turned 45. So basically, try to use the lead-free stuff. It's just healthier for you. These are helping hands. These I'll be using to hold my components. And I went through this over basic tools. There's actually a circuit board holder, a more modern type than the helping hands. Old man, I still use the helping hands. I said this is flux, and just so you can see, let's zoom in on that a little bit. free solder. I'll see if I can put some links in for some of this stuff. This here is a solder extractor. And basically it's just a little air pump. You can get electric ones that are nice. I try to measure once, measure twice and cut once. I really take my time, but even then, every once in a while I have to desolder a component. What you do is you just push down on here, and you'll put this against your component. You're going to add solder. It seems counterintuitive, but you'll add solder to your component that you're going to desolder. And you'll have this right up against it, and you'll have it nice and heated up with the soldering iron, and you'll press this button and sucks the solder right up, theoretically. It doesn't always work like that, which is why I have the solder wick. But hopefully the winds will be with us today and it'll work fine the first time. If not, you'll get to see what a pain in the ass it is, and maybe you'll take your time soldering your components. Okay, so here's our breadboard, here's our breadboard. Here's our printed circuit board. Like I said before, you can get boards that they have no copper on them. They just have holes in them, and you put your components in, and you got to put wires in between them. And it looks horrible. This looks like a lot more professional when you're done, when you use this. So when we look at our circuit design, and keep your paper away from your soldering iron, we see the first thing we have is our plus volts, and we have our diode, and our diode then goes to two components. So if we look at this here, and you could probably see it either way, either on the copper side or on the printed side. You can see our power is going to go in this first rail. So probably the top of this first rail, and that's connected all the way down here. And then we have our diode. Now, before I get into this, let me take out a diodes, resistors, components that look similar. There's two ways you can mount them on these boards. One way, of course, is to have like this, and when you put this in, see if we can get that in there. You put this in and it lies flat against your board. See, like that? Well, there we go. Flat against your board. If you have the space. But let's say you're going from one rail to the next rail. Well, the other way to mount these is like this. Now, see how that is? So what I can do is I can mount this, and I can go from one rail to the other rail without this having to be... Now, it's pretty sitting high above the board, but it doesn't look as silly as if I tried to mount it the other way. So actually that's pretty decent. If I tried to do this, it would look pretty silly. And yeah, we're going to get to the soldering in a minute, guys. Not only does it look silly, but it's hard to put in there. Anyways, I could push that in more, but I think you can see where I'm going with this. It looks awkward. So when we have a small span between the two holes that we're soldering, basically, and it works the same for diodes or anything that is similar in shape. Once again, we're going to mount it like this. That way we can serve space and we can use a smaller proto board. Okay, let's put that back in the parts bin. So the first thing we are going to solder, and I think I'm going to use another board to make a mistake on, is our diode. And I've had to desolder diodes in the past, and the reason why I've had to desolder diodes in the past is because they have polarity and they need to be mounted in the proper direction. Okay, so the way I'm going to mount this component is I'm going to mount it facing up, with this guy facing up. But yeah, let me show you. So remember, the stripe goes towards the negative side. Stripe towards the negative side, non-stripe towards the positive side, where we're plugging in our positive 9-volt battery. But what I'm going to do is, so I'm going to have the stripe facing up because I'm going to mount this just like I showed you with the resistors, because it won't span that gap. Measure twice, cut once. So basically, see here on the white side, and you should be able to see that the silver is at the top. We're actually going to plug our power in here. We're not going to have anything in these other holes. Everything's going to be protected against a reversal of polarity. And so now I'm going to pull these apart a little bit. And we're going to solder this component. Now the reason I pull them apart is so that my component stays in place. And I'm just going to put this in my helping hands, just like that. Now, sorry guys, but I have to solder right, I actually have to use my magnifying glass. And it's actually working pretty good because I managed to keep it out of camera. Okay, so what I'm going to do is take our solder now. And normally when I'm dealing with pure lead solder, what I do is I put the soldering iron against the component until it all heats up, and then I put the solder against it, and actually that worked that time. I put the solder against the component, and then it melts and it adheres to both the board and to the component. So let me try that again. It might be because there's a lot of surface area on this. When we get to the smaller components, it may not work as well. Yeah, see this one? It's not melting. So what I usually do is I put a little solder on the tip of the soldering iron. Now, every soldering tutorial in the world, and don't correct me because I know what they say, they all say to don't put any solder on the soldering iron. Always put it on the component. But putting a little on the soldering iron while it's against the component, what it does is it creates more surface area between the soldering iron and the component, so it's a better transfer of heat. And of course I'm just dipping the soldering iron, and I need a new tip soon, so hopefully we can get through this tutorial with this tip. I use a very small screwdriver tip. Okay, so now it's soldered on here. Can I zoom this in without defocus? No, as soon as I get there it gets defocused. Okay, so now what I want to do is I want to clip off the ends of this component. And I usually save these because if I have to create a bridge between any of these rails, I can just use these, and what I can do is I can bend this. And I can put these in here. Especially these diode ones, because they're nice and thick, so they give they have some nice See how I got that in there? I can actually put it so it's more flush, and then solder it on the other side. And then I have a lot more rails connected if I needed it. So I usually save these and just throw them in my parts bin. I know they usually collect, and I don't use as many as I create, I can tell you that. Actually, I made an antenna out of them at one time. But, okay, so that's a good solder job. I don't know how well you can see that. You just use very little solder, just as much as you need. Okay, so that's our first component, and it was actually soldered in correctly, so we won't have to desolder this one. What I'm going to do is I'm going to try to put everything in correctly. And if we wind up not having to desolder anything, we will put a component in another board and desolder it. I'd like to have this working at the end. So the power will go up in here, it'll flow down here to here. Now in this rail, connected to the power, we have a couple of components. We have our, let's see, from the positive, let's see if I can get this in. We have the diode, and then we have the C on our NPN. I got it right this time. And instead of the potentiometer, we're going to use a 22K resistor. So we have a 22K resistor as well. Now they go to different things. The 22K resistor goes to a place where it connects with another 22K resistor, a third 22K resistor, and our LDR. So let's do the, since we're going to span multiple holes with that and we want to keep the NPN close, let's do the NPN close. So if we look at our NPN, we know the C is, let me get this out. We know the C is right here. So if it's facing us, which this is facing you right now, it actually goes from right to left. C, B, E. So what's another great thing about these proto boards is we can span this power right over here very easily. So C is into the positive, B is the next row, and then E is that third row. And if I push this in a little, let's get it fairly close to where we want it. Now be careful, you don't want to create any solder bridges. We want to make sure that, now in this instance right here, up here, see where that diode is? And then we have our C. It doesn't matter if we create a solder bridge between those two because there is copper connecting those two anyways. But between the other legs, we want to make sure we use very little solder so we don't create a solder bridge between them. Okay, so we have our component. Now remember, measure twice, cut once. Our component, we have positive, B, C, which is positive, B, and then E, which is the negative. And we'll even get a little closer to the board here, and then bend this back a little bit. Okay, once again, I've got my helping hands. And let me get the pen out of the way. And pretty much an NPN, you can solder it without having to worry about burning out the component. I've soldered many of them. So we put it here, we heat up this component, and put a little solder between the component and the soldering iron. It heats it up better, and boom, we're good. We're going to do the same thing over here, heat up the component. If it's not melting on the component, in that case it melted on the component. Here again, and boom. Very little solder, guys. Actually, I think I have a little more solder than what I would really need, but because I did create a solder bridge. Not where I shouldn't have one, but where it doesn't matter. So let me take these off. And as you can see, if you get used to this lead-free solder, it's really not that bad. It's just a matter of getting used to it. Human body can get used to anything. Right now I drink coffee without any sugar in it whatsoever. And that took a little getting used to. Just make sure I clip off. And be careful of these little pieces of components. You don't want them creating any bridges either. And I will give you a closer up look at this baby. The lead-free solder usually isn't as shiny as the lead solder, but okay. So now we have our, it's a little crooked, but that's okay. So now we have our C, B, E. Now, what do we want to do? Do we want to go to the LED, or do we want to go to the our B components, our switch components? And I think I'm going to do the switch components yet, because I'd like to put the ground all the way down here, but maybe, and that would be easy with the LED. I could just run it from here to here, and then the resistor to the ground. But our B is much more complex. We have actually two things going to ground, and we have a 22K resistor going to the B and the other components. So let's do that first. So first let's take our 22K resistor out of our breadboard here. The one that went from B. So we're going to take our 22K resistor, and it's going from B. Now nothing else is going to go in this row, because all the other components are connected on the other side of this. And instead of wasting a row, I'm actually going to mount it like I showed you earlier. I'm going to mount the component like this. And what I'm doing is I'm skipping one. So right now I am skipping one. So now everything else, the other components can go into this rail right here, where we end up. Now I'm skipping that E rail because that E is going to be for, I don't want to connect this to the B and the E, so I skipped a rail and it's in there by itself. And let me move that component, put it here, grab our solder, and oh, that didn't adhere good. Okay. And then over here, same thing. Hold it, heat it up a little bit, throw it in there, boom. Don't need much at all. Okay. Now that second resistor that I was talking about that I put in here, I'll probably put it in. Actually, I'm debating on it because then you can't see the working, this one right here. Then you can't see the working nightlight. So I think I might leave that out. I'm going to show you, I'm going to put it in there and show you where we would put it in. Or maybe we will put it in and then we'll desolder that. Okay. So now we're going from, we have our solder, our circuit board. We have the 22K resistor, and it's going from a single hole where the B is connected over to a whole row. And now we got to see the other components we got to plug into that row. The other components are a 22K resistor that goes from power to that row. Okay, so we got a 22K resistor. Make sure I get the right 22K resistor. Yeah. Okay, this is a 22K resistor. Actually, you know what? Let me measure this to make sure. Remember, measure twice, cut once. Perfect, 22K. So now we have a 22K resistor. Now, feel free to take your potentiometer if you want. This is the 22K resistor. If you want to have an adjustable nightlight, what you can then do is take your 22K, your 100K trim pot and mount it like this, from here to here. See which end that's going into? From there to there. So, and then I would solder this in, and then I would have an adjustable. Whoops. Then I would have an adjustable nightlight, and I can adjust it to whatever whatever light circumstances suits my needs. If I'm really afraid of the dark, I can set it off at twilight. So if you want to do your trim pot, now's the time to do that. We're going to do a 22K resistor because I'm not going to waste a trim pot on this project right now. So we need to go from power over to this rail right here. So power to this rail. Now what I could do is I could go right from here to here, here to here, even up here, any of these guys down to here. But for space constraints, because I still have another 22K resistor and an LDR, I'm going to put it over here. Now, of course, you don't want... Now, if this touches this, I don't know if you can see that. If that touches that, it's no big deal because it's connected in that row anyways. But you want to make sure that these components are not touching anything that they shouldn't be touching. So what I'm going to do is I'm going to mount this across. So this is the first resistor or first component that we're putting in the normal way you would see a resistor in a board like that. So because it spans enough, so I'm putting it right next to the diode and right over here. So let me get this in here. Widen that out a little bit. And on this side too. So that's not touching. Now that is the insulation around the resistor touching the other resistor. That is not going to matter. You don't have to worry about that. So basically, as you can see, I'm going from power, where the diode is. Oh, I'm sorry. See what I mean about measure twice? I'm actually in the wrong, I'm in the positive rail. I need to be into the rail where the power is, now see that? That would have been a mistake. That would have been on the side where the power is, and it wouldn't have been protected by the diode. So I need to take this out and put that side down one more. There we go. I can't stress enough. Measure twice, cut once. It's a pain in the ass to desolder, which you'll see when we get to it. So there we go. So now we're going from protected power. See, this is protected power. This is protected power. Anything along here is, these two are protected power. This is not. We're going to be plugging our power supply in up here. So these here are not. It has to come after. See, this rail comes along here. So now it's plugged in correctly, and I just make doubly sure. Yep, it's connected to the same rail as our other 22K resistor. So helping hands will hold it. Soldering iron. This we'll do over here first. And I had to put a little bit on the tip just to create a better, and I actually created a solder bridge because the component was leaning over too much. Actually, it wasn't the component, it was me. I take responsibility for the solder bridge. Actually, I don't think I created the solder bridge. There's no solder in between the two. Okay, let me put solder up here. Heat up the component and solder. Okay. Just take your time with this stuff, guys. And no solder bridge, and I'll see if I can find these little dental tools online too. These are nice. I'm just checking for a solder bridge here, and nope, there's no solder bridge. Okay. And okay, so now we have our power. Our power is going to the resistor, through a 22K resistor to the 22K resistor to the B. So now what else do we need here? We need our LDR and our other 22K resistor. So let's do the LDR. Now when we do the LDR, we're going to do the LDR a little different. What I'm going to do is, as far as the LDR and the LED are concerned, when I build this into, if I want to put it in a nice little project box and make a professional job. Now remember, the resistors, including the LDR, are not polarity specific, so you don't have to worry about them. But both this LDR and the next resistor are both going to go to ground. So now I'm going to determine where I have my ground. And I am going to use that, although I don't need to. Actually, I'll use this one right here for ground. So hopefully you can see that. But I want to stick this component up. I don't want this component to be down. I want to be able to have this outside of my project box if I have a project box. So I'm actually going to have this sticking up, and I'm going to have the LED sticking up as well. So first what I'm going to do is I'm going to solder this end of it. So I have my helping hands, and that's barely on camera, but it's hard for me to see through the magnifier. And boom. So I did that end. Now I'm going to unpinch this up. I want it fairly even. That's fairly even. And I got some solder on there. Doesn't take much, guys. And actually my soldering is getting better as the day goes on. Okay, so that is in the same rail as the two 22K resistors, and that is going to be our ground rail there. And if I need, I could extend the ground rail to this. I could just take one of those clips and extend this rail over and have a lot more area for ground. So now let's take that other 22K resistor. I really hate it's very difficult to desolder these boards. So let's skip that 22K resistor for right now, and we'll desolder from another board. Let's take, now we have our LED, this big red one. By the way, at night, what affects your night vision more is towards the blue spectrum. If you're creating a nightlight, it's actually better to go to the towards the red spectrum than the blue spectrum. It doesn't affect your night vision as much, and it'll help you go back to sleep if you're just getting up briefly and then going back to bed. Now, there's two ways we can do this. On the breadboard, what we did was we had the LED going from here, and then we had the resistor after it. But it doesn't matter in which order we put these. So I think in this case we're going to do the reverse. I'm going to take the 470 ohms resistor, and I need to go from E, the E portion of the component, and then I'm going to go over to here, just so I can mount this the way I want to mount it. Okay. So this is the 470 ohms resistor. So instead of going from the E to the LED to the 470 ohms resistor to ground, we're actually going to go from E. Now, I'm way over the other side of the board, but I'm on the rail that the E is on. And then I'm going to a rail that has no other component in it. I don't know if you can see that. I should move this back a little so we're more on camera. There we go. There. And then this one. There. Okay, so this row is where the E is. See here is the E, and if we come over to here, that's where I put the 470 ohms resistor. I could have put the LED in there. And you see this, how this metal is touching this? We don't have to worry about that, because this is insulated. This backing is insulated. So let's solder our 470 ohms resistor. And we're just doing this to show you that, you know, there's different ways to line up these components. Side. It's hard to do this soldering with the camera, guys, because I'm trying to leave you guys space to see what I'm doing. And it makes it a little more difficult for me to work it. But I think I'm up for the challenge. Make sure there's no solder bridge in there. No solder bridge. Okay, so now we have the 470 ohms resistor going from E on our NPN to this rail right here, and there's nothing else in this rail. So now we want our LED, and we'll take the big honking red LED. And this has polarity now, so we want the long end on the positive side, which is over here by the resistor, then the short end going into where we're going to have ground. So we'll go from, actually we'll do it from here to here. And this one I want sticking up as well. So yeah, I definitely want to have this one sticking up as well. So, because just in case. I mean, I'm going to cannibalize this anyway, but I'm showing you how I built it initially. Here. And now I straighten up this component a little bit. Now that one's soldered in. And let's solder this one. Hold it here. If I need to, I'll put a little solder on the very tip of the soldering iron so that it connects the component and the soldering iron so it actually heats it up better. And that's what you wondering what I'm doing here? I just want you guys to see, be able to see the component. I'm just cleaning off the tip on that Brillo type pad. And now I'm taking these off, tip off, tip off. Okay, so now we have our circuit except for the power. And I'm actually going to solder the power on this too, because I want you guys to see it working. So without the battery plugged in, our positive is going to go up here. All by its lonesomes. Oh, wrong way. All by itself. Pull a little positive. Be positive. Okay. Positive in here. Very little solder. And it takes time, guys. You know, practice it. And the negative I could put in. Down here we have two components in negative. I can put it in any available hole here. And if you notice, you can see what's connected by this white silk screen on here. So what I'm going to do is I think I'm going to put the negative right in here. Right in that little extra. And what I'm doing is I'm taking the helping hands and it's holding the board and the wire together. So it's holding that wire in there because that wire is not too long. And soldered. Now an actual printed circuit board will probably be a little easier to solder than this. See that little piece there? That little piece, we don't want that connecting anything. Okay. So now we have, let's zoom out. See what I was doing with the soldering iron? Now one of the things I'm going to do, I'm going to unplug my soldering iron. Actually, we're not done, so I'm not going to unplug it. Normally I'd unplug it and I'd tin the tip in there. And then I'd clean it. Yeah, it's almost time for a new tip. I'm surprised it survived this. Okay, so let's shut this off. It's kind of dark, but that's okay. That's what we want for our nightlight. And you can see, this is our nightlight, and it's kind of coming on with the light now. Remember I was telling you that? And I didn't like that, because even though it might look dark to you right now, this is fairly, I'd call it almost twilight. And you can see it starting to come on. You know, we put it more under the light, or if I bend this, see how I did that? I bent that towards the light, and it went dimmer. And then here this way. And then boom. Okay, now let's do a solder extraction. And this over, zoom in. There's our solder extractor over here. Okay, a little fuzzy. Little fuzzy. Okay, you know what I'm gonna do? I'm gonna desolder the. I think I'll desolder. Oh, let's desolder a couple of components. How's that? Okay. Okay, let's desolder the positive. Okay, so one of the first things we do before we desolder. Okay, so let's take we have the plunger here, we have it down. See how I did that? Sometimes these get caught in the rail. So we have that down now. So that's ready to go. We just press that little button. So what we're going to do is we're actually going to add solder here. And like I said, I know that seems counterintuitive. It actually works quite well. Let me move this helping hand out of the way. It's more like an interfering hand right now. So I'm actually adding solder to this. So we got a nice little ball of solder. And then I'm putting this right up against it, and my hand got in the way. Let me see if I gotta do this so you guys can see it. So there's a big ball of solder on there. It's all melty right now, and I put this right up against it, and it didn't take much off of there. And get a decent solder extractor if you think you're gonna be using it. Now, if I had some solder wick, what I do is I just wipe that solder stuff right off of there. But that component can actually. So the component's out. I cheated. I don't know if you saw that I pulled. But we actually have the hole. I could see through that, so I could reuse that. I could resolder that.